the following video presents the general problem of machine learning-based early decision making. This is the second issue of a series of 7 videos which present the main ideas of the founding papers of this new research area. This video is very progressive since it starts with the problem of early classification of time series, which was already presented in the previous video. Then, a more general problem is defined, which is called early decision to be located in time. Finally, the machine learning-based early decision-making problem is presented, for which the other 2 problems are particular cases. This slide shows the ID card of the early classification of time series and its limitations. Each orange word corresponds to a lock which needs to be opened. Indeed, the learning task is a classification problem. The input data consists of time series. The decision period is defined beforehand and corresponds to the length of the whole time series. The decisions are both unique and relative to the whole time period from 1 to capital T. And finally, the decision cannot be changed once made. As a reminder, the training set consists of complete and labeled time series. When using the model, 2 questions must be addressed. First one, when should the model trigger its decision? And second one, what is the event to be predicted? Or equally, what is the class of the input time series? Now, let's continue with the second problem, which is called early decision to be located in time, and which opens the first lock visible in green in the slide. In this case, a decision made is associated with a subperiod that is included in the time period over which the series is defined. Training set consists of complete time series for which the decisions to be made are associated with subperiods. When using the model, 3 questions must be addressed. When should the model trigger its decision? What is the event to be predicted? And finally, when will the event take place? To illustrate this, the following example involves a water turbine in an hydroelectric power plant. For each day of operation, the question is whether the electricity demand will be low enough to shut down the turbine and perform maintenance. We also want to know as soon as possible the time period during which the maintenance operation can be performed. Now comes machine learning early decision making, which is the most general problem and which opens a second lock. Here the training model is capable of making multiple decisions. In this case, the training set consists of examples, each defined over the time period from 1 to capital T. Each example has multiple labels corresponding to subperiods, and the number of labels can vary from one example to the other. When using the model, several questions must be addressed. First, when should the model trigger a new decision? Second, what is the next event to be predicted? And above all, what is the time range associated with this new event? Here is an example that illustrates the use of machine learning early decision making. We consider here a mass market application which runs on a cloud platform. For instance, it can be a video on demand service. During the day, we try to identify as soon as possible the periods of time during which we need to increase or reduce the number of workers, depending on the number of users. In this case, several decisions have to be made during the day. To conclude, in this video we have defined the general problem of machine learning early decision making, and to do so we have opened 2 locks, namely we have presented multiple decisions to be located in time. In the following videos we will present the challenges that we proposed in our position paper in order to develop the machine learning based early decision making area, and we will remove the remaining locks.